Let's do some examples. So some quick little examples here. So if we let u, the magnitude of u equal to 5, magnitude of v equal to 4, and theta equals 60 degrees. Well, let's do the projection of u onto v. So the projection of u onto v from our formula is the magnitude of u over the magnitude of v times cos theta in the direction times the vector v. So we worked out this formula earlier. Okay. Plug those numbers in. Cos of 60 is 1/2. Magnitude of u is 5. Magnitude of v is 4. Multiply it by the vector v, and that's what you get. Okay, so the projection of u onto v is a vector in the direction of v that is 5/8 the length of v. We can also do the projection of v onto u. Okay, so we can do that one over here. So the projection of v onto u, well, it's the magnitude of v onto u, cos 60. The angle between them hasn't changed, so we can still use that, cos 60. And now we're multiplying it by the vector u. Work it all out, and you get 4/10, which is reduces to 2/5 times vector u. So the projection of v onto vector u is 2/5 the length of u in the direction of u. What happens if the angle is 120 degrees? Okay, so same vectors, but the angle is 120 degrees. Well, here's what we get for those. Okay, 120 degrees is greater than 90, so cos of 120 is going to give you negative values. In this case, it's negative 1/2. So the projection of u onto v is going to be negative 5/8 vector v. So 5/8 the length of vector v, but in the opposite direction of vector v. And the projection of v onto u is going to be negative 8/10. That's not negative 8/10. That's negative 4/10. Okay, and that reduces to negative 2/5 vector u. Okay. And if we look at the scalar projection, so if we want to look at just the scalar projection, the angle between them is 60. Well, we're just looking at the magnitude of u cos 60 now. Okay, we're not dividing by the magnitude of v or anything. Okay, so magnitude of u is 5, cos 60 is 1/2, and we get 2.5. So the magnitude, so the scalar projection of u onto v is 2.5 units in the direction of v. The scalar projection of v onto u, when the angle is 60, is 2 units. Okay. And when the angle is greater than 90, the vector is going to go the other way, so our scalar projections are now negative. That indicates it's going the opposite way of vector v. Okay. So that's how that one works out. Let's take a look now at the dot product. Okay, so this is a big one. Okay, so the dot product. This is our first way of multiplying vectors. Okay, the dot product is one way to multiply vectors. The dot product of u and v is defined as u dot v, so a dot right in the middle, not at the bottom, but right in the middle of the two, equals the magnitude of u times the magnitude of v times cos theta. That's how it's defined. Okay, this can be thought of reducing the two vectors into one dimension and multiplying them like real numbers. Okay, so we know how to multiply real numbers, so this is where the projection comes in useful. If you're projecting a vector down onto another one, it's like you're looking at the shadow of one on the other, and then you're multiplying their lengths. Okay, so the magnitude of v cos theta part of u dot v. So magnitude of v cos theta is just the scalar projection of v onto u. Okay, so magnitude of v cos theta is just a scalar projection, as we've seen earlier, of v onto u. Okay, or it's the u component of v, which is another way of looking at it. So when we look at this, if we think of this as the real number line and vector u is on it, okay, then vector v might be something like this if theta was greater than 90. It could be less than 90, it doesn't matter. If we look straight down from the top, then the u component of v, magnitude of v cos theta, would be here. It would be a negative number in this case. And then the magnitude of u would be right there. So we're going to take this number and multiply it by this number, and that ends up being the dot product, as if this is on the real number line. Okay. Let's take a look at some examples. So if magnitude of u equals 3 and the magnitude of v equals 7 and theta equals 40 degrees, let's find their dot product. Okay, so u dot v equals the magnitude of u times the magnitude of v times cos of 40 degrees. 3 times 7 times cos 40 equals approximately 16.1 units. Okay. So in this case, the vectors, the angle between them is in the same direction, and their dot product is going to be positive because it's like multiplying two positive numbers. Okay, so you have a vector here, another vector at 40 degrees to that. You project that down, you take that length from 0 and you multiply by that length. So you're just multiplying this number times this number. They're both positive. You're going to get a positive dot product. Okay, what about this one? The angle is 107 degrees. The magnitudes are not as nice as the other one, so 7.4 and 3.9. When you do the dot product, u dot v, magnitude of u times magnitude of v, cos 107 degrees. Okay, plug it all in, you get negative 8.4. So 107 degrees, that's like looking at these vectors like this, and then the angle between the two is in there, and it's greater than 90. So the projection of this one down is going to produce, if that's 0, that's a positive number, that's a negative number, so a negative times a positive is going to give me a negative. Okay. What if you want to find the angle? Well, say you're given the magnitude of the two vectors and you know their dot product. The dot product's negative. So that should give you a clue that the angle between them is going to be greater than 90 degrees. Okay. So cos theta is u dot v over the magnitude of u times the magnitude of v. If we go up to the formula that was defined, so up here, u dot v is the magnitude of u times the magnitude of v cos theta. If we want to find cos theta, we take this part here and divide it over here. So cos theta then equals u dot v over the magnitude of u times the magnitude of v, which I've written right here. Okay, it's just rearranging that formula. We know that u dot v is negative 5. Plug that in. Okay, magnitude of u is 4.2. Magnitude of v is 16.7. Work that all out. You get about negative 0.0713. Cos inverse of that would give you theta equal to approximately 94.1 degrees. Okay. So that's dot product.